What is up, Internet? It is I again, that guy again, and today we're gonna hack some more Kingdom 1 Hearts, the final mix. And yeah, so last episode, right, we went through, made this cool warp on unpause cheat where if we turn it on and we want to go to warp to a different room, right, we just simply pause, type in the world ID we want to go to, and the warp ID, and we just make it so, right, like if we want to go to, I don't know, let's say Alice in Wonderland, right, and we want to go to warp 0, and we just unpause, right? Just like that, see? So that's the cheat we made last time. Now, the thing that sucks about that is, though, we don't know really where we're going until we spawn there, right? Because we have to edit the warp ID. So what we're going to do in this episode is we're going to find out how exactly the game calculates room ID in order to allow us to use room ID to, you know, warp you, basically, right? So, well, here, we'll go ahead and skip this cutscene. Funnily enough, we haven't found Donald and Goofy yet in the game, but we just magically have them all of a sudden. So that's cool. It's kind of crazy when you think about it. Alright, so now that we're in Alice in Wonderland, we're going to take the room ID, we're going to right click on it, and we're going to say find out what writes to this address, right? Boom. And actually, since we can just use our warp cheat, we'll just turn our warp cheat on, and we'll just pause and unpause. And that will have written the warp ID, or the room ID, right? So now, we'll stop, show disassembler. We're actually going to go, so this is a function here, right? It's pretty easy to see because all the int3s at the start, they're just, you know, think of it like spacers, I guess. So we'll just go to the top of the function where it subtracts 28 hex from the stack pointer, and we're going to set a breakpoint here, right? And we'll just pause and unpause again, so it warps. And so now we can kind of look and see what's going on, right? So we see this memory address with the offset 232E900. It's taking the value there and storing it into the A register, right? Which it seems like this is some kind of pointer to a memory address ending in BB80 or BB80. Sounds nice. Let's go look at BB80 real quick. And so, yeah, we just see a bunch of gobbledygook, basically, right? At least at the start. So what happens after we get the gobbledygook pointer into RAX is it's going to move the value in the C register into the D register, right? In this case, that is the warp ID from what we found last time. So then after it does that, it takes what's in the C register and puts it in RDX. It puts it into this memory address ending E908. And from what we saw last time, I think that's where it actually stores the warp ID in memory. Yeah, it's where it's storing the warp ID in memory, E908. So then, after it does that, it actually goes through and it moves something else into ECX, the value of E5C ending. Let's see. So that's the world ID. Okay, so we grab the world ID. We found out what that is. Now we still have the warp ID in the D register, right? We still have it there. We're going to notice that it does an SHL or a shift left RDX 6, right? Which in English, it's shift left, the shift 6 bytes left, basically, right? And every time you shift a byte left, or bits left, sorry, not bytes. We're going to shift 6 bits left. But every time you shift bits left, you basically multiply by 2 because it's a power of 2. Just like if you shift left with the decimal, it multiplies by 10. And if you shift right in decimal, it divides by 10. If you shift left in binary, it divides by 2, right? So what we're going to do real quick, we're going to go and we're going to look at the handy dandy calculator. And we're just going to say, like, what is 1 shifted left 6 times? It's 40. 40 hex, 64 decimal, right? So basically, so like this is if it's 1, right? If it's 1, if the value in dx is 1, it's going to be 64 decimal, right? If the value is 2, it's going to be double that, right? It's going to be another 64. So every 64 bytes, 80 hex or 40 hex, I guess, every 64 bytes, something new. So if we say, like, because it's hex, we have to do here, it's going to be plus 40. And then we say, like, plus 40. So we're going to notice, right, this one starts with a 1. The other two started with a 0, right? So then we're going to see actually the next line. What happens is it takes the value at RAX, which is the BB80 value we noticed earlier, right? That pointer, and it actually adds RDX, which is the number we're looking at here, right? Which is basically 64 times X, where X is the warp ID, right? And so it's going to take the byte there, which in this case, or it's actually taking the 4 bytes there, which in this case is 1 for what we're looking at here, which is the warp ID 0 based on what, or I'm sorry, warp ID 2 based on what we're seeing, because they start at 0, and 0 was 0, 1 was 0, 2 was 1, right? 2 is room ID 1. That's actually how we kind of traverse the structure, it seems like, to find the room ID. So now you might wonder, like, where do we go from here, right? So what we're wanting to do is we're wanting to take the room ID. We're wanting to then traverse the structure of warps until we find which warp exactly contains the same room ID as the one we're looking for. And once we do that, we just want to set our warp ID to that value and then run the same function we've already got. So let's see how we would program this. Apologies for all the cuts. I'm having some weird congestion going on. We're actually going to stop our breakpoint and start the game up some more so we can just have some nice background music going on while we're doing our spooky hacks. We're going to turn off our warp on unpause cheat. We're going to right click and we're going to say change script, right? Now, when we're in here, we're going to remember that at the start we did all these pushes. We pushed all these registers to the stack to preserve their state before we do stuff that would change them, and then we pop them back afterwards to maintain state for all the code that comes after. So let's actually go back and see, because the first thing we're going to need is we're going to need to go and get the pointer that leads to the start of the warp address, right? Or the warp table. And so it looks like this 232E900 is the offset, right? From the start of the process memory. So we're going to go and we're going to, after pushing all this stuff, we're actually just going to say move into, since we're preserving the A register, well, let's think. I might just see if we can just use the C register and only use that one, because that's where we push our parameter into. So maybe we can play it off and only need one register for the whole thing. All right, so we're going to say move RCX, and then we're just going to say the square brackets to say the value at, right? Kingdom Hearts final mix .exe in quotes plus the offset, right? And that's going to basically take that warp table and just put the the pointer to the current warp table, I guess, because that pointer to the current warp table is stored at the E900 address. In this case, leads to BB80 or BB80 because it sounds cool. So now we have that in the RCX register, right? We're actually going to need 2 registers. So what we're going to do instead, we're going to move that into RAX. Then next, we're going to do a little trick, right? We're going to say XOR RCX, RCX, right? It's going to make no sense, right? But this basically moves 0 into RCX, right? And what it is it's an exclusive OR. So there's these things called bitwise operations like AND and OR, and not AND, NAND, or XOR, or for exclusive OR, right? And essentially what this one is, exclusive OR, it just takes every bit in the number and it says for every bit, if one of these 2 bits is 1, or basically it says if these 2 bits are different, then make it a 1. If they're the same bit, make it a 0, right? For every bit in the number. And since the 2 numbers are the same exact number, it's just going to say that they're all the same for each one of them, right? Meaning 0 for each one of them. They're not exclusively or, exclusively this or that, right? Because they're AND. So because of that, it sets RCX to 0, and it's just a little bit more efficient, like on the processor level. There's no, you could just say, if you wanted to be normal, you could say move RCX 0, right? Same thing. I just like to be fancy. XOR RCX RCX, right? So that's going to set the C register, which is traditionally actually a counter register, right? So it's kind of cool we're using this in the correct manner. So next what we're going to do is we're actually going to use something like a loop, right? So we're going to actually full screen this to make it easy to see. Sorry about that. We're going to go up to these labels at the top and we're going to type out label, parentheses, loop. Yeah, actually let's say warp loop, just in case. So now we're gonna type warp loop and put a little colon there, because that's where the label is. That's where, you know, because in the loop we're gonna have to do code and jump to the code and do code and jump to the code, right? So now we honestly, we can do it an easy way. So what I would say is we would say compare CMP. Oh, you know what, dude, we forgot something. We have to take the room ID. We have to get the room ID and figure out that. So we're also preserving the D register. So we can say move RDX, comma, Kingdom Hearts, final mix.exe. And then we're gonna have to find the offset for the room ID, which it looks like is 2340 EC4. Boom. And we're just going to plug that in. Sweet. So that's going to move the value that's stored there into the D register. We may as well say EDX, because EDX is a 4-byte, RDX is an 8-byte, and this is a 4-byte value. Doesn't really matter, I guess. You could do either, but, you know, may as well, right? So actually, you know what, it might matter, so yeah, just do EDX while you're at it. But yeah, so we've got that. So now we would say this, right? We would say compare the value in EDX, right, to the value stored at the memory address referred to RAX plus RCX, right? And after that line, we're going to say JE, or jump if equal, right? And we're going to have to actually make another label. We're going to call this one warp. You know what? We don't need to do this. We can be even cooler. We're not going to make that new label. Instead of JE, jump equal, or jump if equal, we're going to say JNE, or jump if not equal. Because if it's not equal, if it's not what we're looking for, we want to go back to the warp loop, right? Ooh. Y'all, we got to do this a different way though, because we're going to have to start at 0. We're going to have to add 64 bytes every time to the address we're looking at. So we can't do it the cool way we wanted to. Never mind. We're going to go back up. Instead of not making the extra label, we're going to make the extra label. We're going to call it warp end. And so we'll use JE, jump if equal, JE, jump if equal, warp end. And we're going to go down here, we're going to say warp end, right? Put the colon. So that's what it'll do after we find the thing we're looking for, right? But let's say this. Let's actually, before the warp end colon, before that label, we're going to put a JMP warp loop, right? So if it doesn't jump to warp end, it's going to jump to warp loop. It's going to go back and continue the loop, right? And in between that, we're actually going to say add RCX 40, because this is hexadecimal, and 40 hexadecimal is 64 bytes decimal, right? So it's going to add that amount and look again. And so, yeah. Let me think. Okay, sweet. So we're just adding the 40, the 64 bytes and doing the stuff, right? So now, here's the thing though. We're adding 40 bytes, right? Or I'm sorry, 64 bytes, 40 hex, right? But the warp IDs, they don't increment in 64 bytes. So we're going to basically have to divide by 64 to get the warp ID by the end, right? By the time we actually use it in the C register. So we're going to go through, and after warp end, we're actually going to say shift right, SHR, RCX 6, because we know it's a shift left 6, so shift right 6 would do the same thing. And then this actually should work. We'll say okay, it'll override. We're going to try it. Let's go and let's say room ID 1. Let's hope it doesn't crash. Unpause. That didn't do shit. Hold up, let's try it again. Huh. Weird. Let me try locking it maybe. Okay, so you just have to lock it, I guess. But that did in fact work. This did take us to room 1. This also, for some reason, I think it put us in the boss. Oh fuck. Hold up, let's go back. Oh, wrong thing. Actually, you know what? Let's go to a different world. Let's just say fuck it and go to a different world. Let's go to Tarzan. What rooms can we get ourselves into? Hippo's Lagoon, Jungle Vines 2, Climbing Trees, Treetop, Jungle Tunnel, Waterfall Cavern. That could be cool. Well, no, that's like a regular area. Cavern of Hearts. See, the problem is I've shown so many like cool, like spooky areas before. Like the novelty's kind of gone for a lot of them. I do know one thing I've seen before is that if you set the scene ID to 12, a lot of rooms load like a debug room instead. So if we were to do, you know, this and set these values, just teleport. Then there's this cool little thing that I've shown off before that just, you know, says weird text and then vanishes away. Or we could teleport to, let's see, let's go to room, or, oh, you know what? We could go to Winnie the Pooh. Well, nah, let's not go to Winnie the Pooh. Let's go instead to Aladdin, because I have some stuff I could show off there too. Actually, room 0. So sometimes you'll notice this, right? It's just a blank area, and that's because the warp table doesn't always load until you're already in the world. So just pause, unpause, and sometimes it'll fix itself, sometimes it won't. That's kind of strange, ain't it? I wonder why not. I wonder what's giving us issues. There is 2 deserts. Let's try this. Let's try to just undo the room ID thing, right? Maybe let's undo that. Let's just see what happens. Okay. Cannot explain it. Not even if I tried. For some reason it's setting us to room ID 1. That's weird. Oh, Jesus. But see, it's also loading. That's the right stuff way over there for the right room. Okay. So something's not going correctly here. Let's take a look. Let's go through. Let's actually set a breakpoint here, right? Boom. Unpause. Alright, very good, very good. We're gonna actually toggle that breakpoint step out, right? So we can go to our custom code, see what's going on here. And so let's just put a breakpoint here, run again, and then we're going to pause and unpause. And then now we can kind of see a little bit what's going on. I don't like the weird graphical glitches that are occurring. It's not my favorite. Let me see. I'm trying to get those to go away. There we go. All right, so let's see. So we're moving the value that's stored in that the warp ID table thing. So that's BE40 in this world, it seems like. And then we're taking, let's actually go and look at that BE40, right? Let's go see what's going on over there, how they're doing on that side of the world. So for some reason, it actually starts with a 1 here. Huh. Who would, I don't know why. I don't know why, but we're just gonna keep our eyes on this. We're gonna keep our eyes on this and see what goes on, right? So for some reason this one starts at 1. I guess it would be, that's another 48. Huh, that's weird. It's very weird. Anyway, so we go from there. We move the value into EDX. That's the room ID we're aiming for, I think. EC4 ending, right? EC4, yep, room ID. Very good. And then we set RCX to 0 if not already, right? Boom. We're going to compare the value there to 0. It's not going to hit, so we're not going to jump there. We're going to add 40 to RCX. We're going to jump back there, going to compare, not hit because we checked the second one. We're going to compare, not hit because we checked the second one. Da-da-da-da-da-da. What we can also do, we can put a breakpoint here and we can just run and it'll continue until it hits. Actually, let's put the breakpoint. That's the jump if equal. That's going to jump to this one. Let's put the breakpoint on this instruction instead because that's where it's hitting. So we're going to run. All right, cool. So it took until 10 CO until it found what it was looking for, right? And then when it did, that's 43. That's warp ID 43 to hit room 0. That doesn't sound right. It sounds like there's some weirdness going on with this warp table or like where it's starting. Very strange. So let's do this. Let's continue. Let's continue. Let's see. It calls the function to load the room, right? BE40. So that's weird because that's the same exact pointer. So let's try this, right? I'm curious, right? So we just moved ECX into E900. It is 0. It is port by ID 0. It seems like it's trying. Wait a second. Why is it trying 0, dog? Hold up. We thought it was like warp ID 43. Something's not right. Something's very not right. So let's run through 10CO. Step. All right, cool. So it's moving. Oh, wait a second. Wait a second, bro. We just overwrite the value in ECX with the warp ID. Man, we didn't even catch that. We thought it was working. So let's do this. Let's remove our breakpoint. If you press Control B, it shows all your breakpoints. Just delete that breakpoint, right? We're gonna run. And now, man, this is so cursed. Very cursed. So let's go and let's delete this for a second. We're gonna edit it. We're gonna change script. We're gonna go in, and instead of actually copying, what I meant to do is I meant to like move the ECX into the warp ID, but you don't have to because this function is going to do it anyway. So we're just going to delete this line, and then we're going to say OK. And now unpause, repause, and we're going to have to turn the cheat on. I forget. Unpause. There we go. We fixed it. We got some weird things going on with the text because we bugged it all out. But this is the Agrabah debug room. And the cool thing about the Agrabah debug room that I've shown off like 3 times on my channel because I love this debug room is you can examine this. Oh, and okay, so we've fucked the game very badly with our cheats. Normally it says test move turn, but right now it's just like nah because we broke in the game. So I'm actually going to reload this so I can show this to you guys. Alright y'all, we've reloaded the save. We're back in the game. So now we're going to turn on our warp on pause cheat, right? We're going to set the room ID to 0 because that's what it goes based off of. We're going to set the world ID to, it was like 6 or 7 or 8 or something, I think. It was 8. We're going to unpause. Fuck, we forgot to set the scene flag to 12. So, like I said, sometimes the warp table is all jank because, you know, you're just jumping between worlds. So, like, this is without us setting the right scene flag. And so we're going to, funnily enough, so Donald and Goofy aren't here. I guess until you hit a cutscene that provides them, they will not be in the game. But if you hit any cutscene that provides them, it'll provide them, it seems like. So let's do this. And it actually is warp ID 67 to get room 0 for some reason. I don't really know why, but it's working. So set the scene ID to 12. Unpause. Oh no, I guess for some reason the Agrabah debug room provides Donald and Goofy. If you don't already have them already. Well, we learn something new every day. Where's our test move turn barrel? I need that test move turn. It's the only thing that keeps me going. So yep, test move turn. And it moves and it turns the box. It'd be crazy if you could like hack it to instead of changing the box, like changing Sora. I mean, I wonder, kind of wonder, but maybe we'll save that for another episode. Anyway, I appreciate y'all's time and I'll see you soon.